Hello student, let's try to see a topic student variation of conductivity and molar conductivity with concentration. We are talking about the weak electrolyte. Here we will see student weak electrolyte because for a strong electrolyte we have already done. So we are talking about the weak electrolyte, how it is going to happen. So let us see student how the slides is saying. Now we got to know that is weak electrolyte dissociate very less in quantity. Okay, so first of all, that is we have to know that is degree of dissociation will be lambda m at the given concentration divided by lambda m at infinite concentration. Second one, we should know Ka is equal to C alpha square 1 minus alpha. These two things we should know. For weak electrolyte, dissociation constant is what? C alpha square 1 minus alpha, and alpha is what? DOD, that is degree of dissociation. Now let's try to read this one. What the topic they are saying. Weak electrolyte like acetic acid. Acetic acid is a weak electrolyte student. Have lower degree of dissociation. Lower degree of dissociation means less than 100%. Means it is ionizing student very less in the amount. At higher concentration, so lower degree of dissociation, even the higher concentration. If the concentration is higher is there, still it is the less dissociate, and hence for such electrolyte the change is lambda m with dilution is due to increase in degree of dissociation, and consequently the number of ions in total volume that contain 1 mole of electrolyte is what is going to happen student, that is going to see increase. It is the when you are diluting the number of ions is going to increase. Here you see in such cases lambda m increases steeply. Okay, now you can read once more. Higher concentration, hence such electrolyte, the change in lambda m with dilution is due to increase in degree of dissociation. So if you are changing the concentration, degree of dissociation increasing means number of ion increasing, and consequently the number of ion in total volume of solution that contain 1 mole of electrolyte. In such case lambda m increases steeply on dilution, especially near lower concentration, especially near lower concentration. Therefore, lambda m naught cannot be obtained by extrapolation of lambda m to zero concentration. That is, lambda m naught cannot be obtained by extrapolation of lambda m to zero concentration. At infinite dilution, that is concentration C giving 0, electrolyte dissociate completely, alpha equal to 1. But at such low concentration, the conductivity of solution is so low that it cannot be measured accurately. Therefore, lambda m for weak electrolyte is obtained by using Kohler's law of independent migration of ions. Example 3.8. At any concentration C, alpha is the degree of dissociation, then it can be approximated to the ratio of molar conductivity lambda m at the concentration C to the limiting molar conductivity lambda m naught. Thus we have alpha is equal to lambda m upon lambda m naught. But we know that weak electrolyte like acetic acid Ka is equal to C alpha square 1 minus alpha. So we can solve this one. So Ka is equal to C alpha square 1 minus alpha, and alpha they have given how much? Lambda m upon lambda m naught. So we are plugging the value C. So here will be lambda m square divided by what? That is the lambda m naught square total divided by 1 minus what is going to be happening, that is lambda m upon lambda m naught. So this is there. Now what we have to do, we have to solve this one. So see lambda m square, this is there, here is lambda m naught square, here is 1 minus lambda m naught. lambda m upon lambda m naught. First of all, what we need to do, we need to solve the bracket, then only we can do. So c lambda m square is there, and if you are solving the bracket lambda m naught square, here is the lambda m naught minus lambda m divided by what is there, lambda m naught. So this is going to be the multiple, so it is going to be divide. So c lambda m square, it is there outside bracket lambda m naught, in bracket lambda m naught minus lambda m. So this is what the K dissociation. You can check this one, this will be the correct one. Here is the c lambda m square lambda m naught in bracket lambda m naught minus lambda m, c lambda m square lambda m naught minus lambda m. So this is what. Now application of Kohler's law. Using Kohler's law of independent migration of ion, it is possible to calculate lambda m naught for the electrolyte from lambda naught of individual ion. Moreover, for weak electrolyte like acetic acid, it is possible to determine the value of its dissociation constant once we know the lambda m naught and lambda m at given concentration C. So this is what. Thank you.